Hello everybody. I'm Andy from ThinkMo. CCIE courses are now being taught. As of today, I'll share with you some technology related to CCNA, CCNP, and CCIE. Our topic today is the DR cannot be preempted. Our main question today: why can't the DR be preempted? First of all, the first one, what are we talking about DR? In the last project, we've already covered that. DR is the OSPF-MA, or in the NBMA environment, router role. And then the second aspect. That's what DR does. First, it can reduce the description information of neighbors. The second thing is you can reduce it. Double calculation of SPF. The third is that it can be accelerated. Convergence rate of the network. Based on these 2 points, it's kind of a review of what we did last time. What we're going to do today is, let's talk about the third question. This is because DR is the OSPF-MA, or in the NBMA environment, router role. What it does specifically. Let's go through the simple description in the last video. I got it. So why can't the DR be preempted? We need to study it in detail. First of all, in the process, I came up with the concept of pseudo-nodes. What is the relationship between DR and pseudo-nodes? The first thing we need to know is what is a pseudo-node. You can think of it as it is an OSPF-MA, or in the NBMA environment, a virtual router. How does it work? So let's look at this graph. Under normal circumstances, R1, R2, R3, and R4 are shared links. So let's look at the second picture. In this picture we see, in this shared link, there's an extra router. I named it after the pseudo-node. This router is what we're talking about. Virtual router. So virtualize this router. What does it matter? Actually, the dummy node, this virtual router. It has to do with DR. So why elect DR? We've already talked about that. So on the other hand, there is one more important reason. We all know about the OSPF network is using RID. It's called the router ID. It is the unique identifier of an OSPF router. It's in a lot of routing protocols. It's all involved. We won't go into too much detail here. The RID is a unique identifier for a router, which means that in MA or NBMA's network, it is not repeatable. So R1, R2, R3, R4 all have RID. What is this virtual router identified by? It uses the DR interface IP address to identify. For example, the IP address of the DR interface is 192.168.1.1. At this time, this IP address is going to act as RID of this virtual router. So why do you do it? I think that's pretty clear to you. RIDs are not repeatable. I can't use R1. You can't use R2. R3 or R4 won't work either. In this case, let's say the R1 RID. It could be 1.1.1.1. Indicates the IP address of the interface. You can use the IP address of the DR interface to describe it. So speaking of which, what we talked about in the last video. Example: reduced description of the neighbor. It's reduced by pseudo-nodes. So how did it decrease? Neighbor information It's also descriptive. If you don't describe it, there's no message. They won't be able to match your description. This is what we refer to as link state information. To calculate the routing information, that means the neighbor information has to be described. but you can't repeat it. So what if you have one more router? Buy an OSPF router. Just describe the connected ones. This pseudonode. It also just needs to be described. The pseudonode to which the virtual router is connected. Same thing with R3. Same thing with R4. If the class can't tell the difference, you can take a look at my last issue. Last time we talked about this thing right here. It's a little bit more descriptive. That's based on this situation. I just need to describe less information. Once each OSPF, the router sends packets from each other. Let's say R1 has 3 devices. R2, R3, and R4. All received this description message. They were all found to be connected. The virtual router in the middle. At this point, R1 is going to think they're on the same network. Again, this involves us. What we did last time. So is R1 from the neighbor. In some of the description messages sent, knowing that we're on the same network. It is a shared link. So at this point, in calculating this information, I can calculate this directly. It doesn't have to be like the last video. We're doing the same thing. Describe the information separately. If you describe the information separately, when the other party receives it, and you have to calculate it separately from that information, so it becomes repetitive. In this case, reduced description of neighbors. That means fewer SPF calculations. Of course, you calculate the decrease. Things are repetitive. If you don't have this virtual router, there is no such thing as a pseudonode. It means in the network, there is no concept of DR. Then you won't know about us. On the same network, then you have to describe them separately. So DR cannot be preempted. The next question is actually a very simple one. What does DR do? Let's say I have a new router. It just jumped right into the network. I'm going to call it R5. Then it became DR. Once he became DR, you have to use the IP address of its interface to serve as the identifier of this virtual router. It has to be the identity of the fake node we're on. So for other routers, you have to redescribe the neighbor information. SPF has to be recalculated. The network was normal. Each can forward data. Because it's a new piece of equipment. Now we have to recalculate. It's a little bit of a hassle. So this is DR can't. The primary reason for being preempted. That's all for today. If there are any other skills you would like to learn, feel free to leave a comment or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thank you. See you next time.